In this video, we're going to solve a problem using AMGM inequality. Let's take a look at the question first. A farmer wants to fence in 60,000 square meters of land in a rectangular plot along a straight highway. The fence he plans to use along the highway costs $2 per meter, while the fence for the other three sides costs $1 per meter. How much of each type of fence would he have to buy in order to keep expenses to a minimum? And what is the minimum expense? Now, in order to solve the problem, let's first draw a graph illustrating what's happening in the story. So I'm going to assume this is a highway. And let's draw a rectangular plot to denote the land that the farmer is going to put the fence on. And I'm going to assume the side along the highway to be of length x meter, and then the other side, we actually know how long it should be because we know the area is 60,000 square meters, so the other side has to be of length 60,000 over x meters. So our job is to find out what this x should be in order to keep the expenses to a minimum. Okay, so let's find out what the cost is for the setting now. So cost C, which is going to be a function of x, will depend on the length of all these four sides of the rectangle. And notice the fence along the highway, which is this part, has higher cost, $2 per meter. So the cost here will become 2x. Well, for the other three sides, they all have cost $1 per meter. So I would have, this is x meter as well, so that's x dollar, and then 60,000 over x for this side, another 60,000 over x for the other side, which turned out to be 3x plus, these two terms can be put together, 120,000 over x. So this will be the total cost, and we want to minimize the total cost. Based on AMGM inequality, the sum of these two terms will be greater than or equal to 2 times square root of the product of them, which turns out to be 2 times square root of, notice these two x can cancel with each other. I would have 360,000, which turns out to be $1,200 in total. So apparently the minimum cost for the farmer to build a fence will be $1,200. And what would the minimum cost happen? Based on AMGM inequality again, we know that the equality will hold when these two terms share the same value, in which you can solve the value of x, which would be 200 meters. Okay, so apparently, if the farmer decides to build a fence of 200 meters along the highway and 300 meters along the other way of a rectangular shape, then the cost will be minimum, which is $1,200.